Hello, everyone. My name is Rob Higuerita, and I'm a Principal Technical Account Manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower costs, and provide you with best practices and design considerations. Joining me today, we have some special guests, though, from Spreaker from iHeartMedia. Can you give us a quick introduction, Rocco, and then Emanuele?
Sure thing. Hello, everybody. My name is Rocco Zanni. I'm Chief Technical Officer at Spreaker from iHeart. I'm Italian, but I'm based in Spain.
Hello, everybody. I'm Emanuele, engineering manager at Spreaker. I'm Italian, but not like Rocco. I'm based in Italy.
Thank you both for joining us today. Really appreciate it, especially given that it's a little bit later in the day for you all. So thank you so much for sticking around and being with us today. And today, audience, we're going to be introducing you to how Spreaker leveraged AWS Serverless technologies to improve their podcast delivery network. And we'll specifically focus on the journey and how AWS Support helps Spreaker to implement these new technologies and how their design reduce the cost and improve performance. But before we dive into all the details, we're going to ask you to feel free to use the chat window on the right-hand side of your screen to let us know where you're joining us from today, whether it's from Spain or Italy or from the US, wherever, and share your thoughts and questions throughout the episode today. We really do look forward to hearing from you. So I'm also going to provide a link to a survey in the chat that you can use to let us know how we did. So please click that link and leave us your feedback. So I'm going to kick us off real quickly just on some past episode information, a little bit about what we're going to be talking about today, and then I'm going to hand it over to the experts from Spreaker from iHeart here after I go through a couple little items here. So maybe you've caught some of our shows before that we've done talking about leveraging serverless environments. We covered one handling answering a question from Repost, where we shared a lot about talking about hundreds of thousands of customers adopting serverless technologies, one being Lambda. We have many more, of course. And that's leading to trillions of AWS Lambda executions per month, because we see the value there being able to take advantage of something that runs when you need it to and doesn't when you don't, and therefore saving you cost and giving you some flexibility there. So I just wanted to highlight a little bit there. I'm going to drop some links into the chat as well, specifically covering some of the past episodes that we did cover about serverless architectures, where we really did talk about going into things like how you can reduce the amount of do-it-yourself that you have with using serverless. So things that you manually had to log into servers to take care of, even just little administration tasks, setting up environments, tearing things down, being able to take that, leverage it as infrastructure, put it into some Lambdas to do the work for you, right? So that as you migrate to AWS, whether you start with the lift and shift, where you just purely take your on-premise environment, load it into EC2 instances like you would have regular servers, and start with that process, and then move later on to modernize on AWS using things to replatform, refactor, take advantage of things like our different serverless service that I'm going to let the Spreaker team speak of much more in depth, because they are definitely the experts on this. So once again, all together, we're going through looking at things being really small pieces, loosely joined is the goal. And so we have all these different services here from Lambda and S3 and SQS and simple workflow and DynamoDB that maybe you don't think is a serverless technology, but really is, because you're not actually setting up instances and servers that you have to administer that help you to build these different platforms that you can use for your clients, whether they be coming in from client computers or mobile devices, and being able to help quickly implement things in a more quick fashion. So again, I'm going to turn it over to you, Rocco, and turn it over to the true experts here from Spreaker, from iHeart, to give us a little insights into their environment and how they did things. So thanks again for joining us. I'll turn it over.
Rob, thank you very much again, and hello to everyone. My name is Rocco Zanni. I am CTO at Spreaker from iHeart. We are a podcast platform for content creators who want to turn their passion into a profession. We offer tools to manage the entire podcast lifecycle: creation, distribution, and monetization. We started this adventure in 2009, but since 2020, we are part of iHeartMedia, America's #1 audio company. Next, let me share some numbers with you. In April, just a couple of months ago, we served more than 400 million IAB certified podcast downloads for a total of 25 petabytes of audio delivered through CloudFront to listeners all over the world. We give creators the ability to distribute their content everywhere and to monetize thanks to the dynamic audio insertion into podcast episodes. That may seem straightforward, but there's actually more than meets the eye. First and foremost, because the main peculiarity of the podcast industry is that a podcast episode can be distributed and listened to across a wide range of platforms. We have Spreaker itself, but we also have Amazon Music, Apple Podcast, Spotify, and so on. So while this is great for the creators because it gives them the opportunity to reach a very wide audience, at the same time it creates a challenge for the hosting platform when it comes to delivering these contents. We don't have any control on the listening application, so we have to figure out a way to deliver dynamically inserted audio advertising without relying on the client doing anything about downloading a single file over HTTP. Our solution to the problem, as represented in the next slide, is an HTTP-based podcast delivery network with dynamic ad insertion happening on the server side. As I was saying before, because we cannot manipulate the audio on the client, the only solution is to deliver a dynamically built audio stream containing both the original episode and the right advertising stitched together. Let's make a practical example. What happens when you ask Alexa Echo to listen to the latest episode of your favorite podcast? Well, first of all, Echo sends an HTTP request to our download API that, based on the content metadata, like the podcast category or tags, and the listener information, for example, the IP address and user agent, create a target for compatible advertising to be inserted into the episode. Let's say that the listener is in America and the podcast is about technology. The platform may look into technology-related advertising in English from advertisers in the United States. Once we collect this information, the client is then redirected to another service that we call the Stitching API that is responsible for the actual building and delivery of the dynamically generated audio stream. This stream could be composed, for example, by an ad, followed by a few minutes of the episode, then another ad, and then the rest of the episode. All of this is done in real time without having the need to use a previously assembled stream. So at this stage, Echo is already playing the stream for you, but there is one more thing we have to do, that is tracking the actual delivery of the ad to the client. Now, this is what Emanuele will cover in the second part of the session, but to oversimplify it, we can say that we need to track every time an ad has been successfully transferred to the client in order to signal the advertiser that an impression took place and to attribute the revenue to the content creator. So I guess now you may want to ask yourself, why am I talking about podcast delivery in a presentation about serverless and event-driven? Well, the answer is very simple. We are here to share our experience on building serverless event-driven application in the real world, not only for new products, but also to evolve a core product of your business because you need to scale, or because the industry is changing, or to reduce costs, and so on. And this is exactly what happened with the podcast delivery network. And in the next slide, we're going to cover how the platform looked like a year ago. So after building and growing this platform for a few years, we have to face that in order to keep growing in an industry whose size is basically doubling every year, we needed to radically change the way we approach the problem. But what were the issues with this approach? Well, first of all, parts of the platform were tightly coupled with the hosting services. For example, let's say that a front-end developer was changing some CSS on the Spreaker website. That release could potentially impact also the download API, which purpose is completely different. That's to take care of podcast delivery. This tightly coupling was also forcing some service-to-service communication to happen across AWS regions, because the hosting platform was in Europe, together with the download API and the tracking services, but the stitching API was both in Europe and the US in order to be in the same region where the audio files are stored. We also had multiple data storages with different scaling needs and techniques, so S3, Postgres, and Redis. The usage of serverless and managed services was very limited, and so the rest of the architecture was tricky to scale up and down without human intervention. Plus, everything was deployed in the same AWS account, creating obvious risks when it comes to workload security, isolation, and reduction of the blast radius if something goes wrong. So what did we do? Well, we sat down together virtually, and with the help of our AWS support team, we drafted a new architecture. We evaluated the costs, and in this slide, we show what we came up with. We wanted to decouple the download API and the tracking service from the hosting platform and have them running on Lambda. We want to have a single storage, S3, to be used also as a key value store for data that you would normally have into a relational database. We want to be able to spawn a copy of the platform into an arbitrary number of regions, completely isolated from each other. And we want all of this to happen in a new dedicated AWS account. So, as I mentioned, this was last year. So let's fast forward to today, and let me talk to you about the outcomes. First and foremost, our architecture has been successful because we built the platform as we intended, and we have been running at scale in production for 4 months, and our life significantly improved. The total cost of ownership was dramatically reduced with the same performances and operating costs. We now have the ability to scale the platform to at least 10x the traffic we are sustaining right now. And choosing S3 as our only storage gave us high availability, scalability, multi-region support, lifecycle rules, and the ability to build event-driven workloads. Last but not the least, the ad tech team was, and it still is, a two-pizza team, even though the pizza to humans ratio works a little bit different with Italians, and is able to efficiently develop and manage a global scale podcast delivery operation. I want to now pass the baton to Emanuele, that will cover the details of our event-driven approach to develop the tracking service.
Hello, everyone. I'm Emanuele, engineering manager and speaker from IART, and one of the teams that I currently managing is the ad tech team, and that's why I'm here today. In the first part, Rocco gave you the big picture of what we did, and I'm here to dig a bit deeper to explain better the advantages of using an event-driven architecture in our context. We will do this looking at a specific core feature of our platform that was already anticipated by Rocco, that is the ads tracking service. The main goal of our podcast delivery network is to serve media as fast as possible to our users in a reliable way. Keep in mind that we deliver mainly dynamic media with stitched ads. When we designed this component, we started from some simple core principles that are this one. We want to traverse the hot path only when it's necessary. So a single combination of a podcast episode and a specific ad should be cached as much as possible to make sure that we're not generating again and again and again the same meta stream. We want to minimize the impact of every other computation that is not necessary for the delivering experience. Now, leveraging media mutability through our whole stack, it is pretty simple to understand that just by putting a CloudFront distribution in front of our stitching API and crafting immutable IDs for the stitched media, we can achieve this goal. The problem with this approach is that we still need to track when ads are downloaded on a third-party system to make sure that we can attribute revenue correctly to our content creators. Something that is pretty straightforward to do if you always hit the origin, requires a little bit of creativity when 90% of the time the users are just pulling bytes from a media variant in a CloudFront distribution. That's where AWS Event come to the rescue. So we configured the CloudFront distribution to drop access logs on an S3 bucket. We then leverage the fact that we can subscribe to file creation events in S3 and start doing some work from there in an async fashion. In the next slide, we can zoom in a bit and see how we kickstart different computations from logs dropped in S3 buckets. Keep in mind that we have more, but these are just two examples. We use the combination of SNS and SQS to start several workflows. The first one that you can see is a workflow to enrich and archive the logs with our domain-specific data. And this one was particularly useful to provide specific access to some of our enterprise customers for auditing and reporting purposes. We implemented then another flow to actually keep track of the downloaded ads that must be reported back to third-party system in order to have revenues correctly attributed. It is important to note here, this is a little technical detail, that the presence of SNS is necessary to do the fan out from a single event to multiple queues. Let's now skip to the next slide and take a look on how we implemented the process log service. Again, we are a lot of small things doing different things together. we're looking at one process and two decoupled services once again. On the left, you can see the log processing service, where we keep track of the downloaded byte ranges. We understand the context of the download for extracting attribution information, and we decide if an ad should be tracked or not. If the ad must be tracked, we then pass the ball to the next step. The track impression service on the right, it is just responsible for invoking tracking URLs on third-party system that will then actually attribute the revenues correctly. Worth to notice here that we never directly call one Lambda from another Lambda, but we always put an SQS queue in the middle. This gives us some nice advantages if we keep the execution of the Lambdas idempotent. The first one is robustness against temporary unavailability. We can arbitrarily increase resilience, tuning retries, and visibility timeout. The second big one is that the fact that we don't lose data. When something fails, nothing is lost. It just goes in the dead letter queue, if configured correctly, obviously. And then we can add simple monitoring and alerting, just looking at the presence of messages in the dead letter queue. And the last but not least is the simplified recovery from failure. In case of failure, we can always redrive the dead letter queue without losing anything. But this is very good in theory, but let me give you an example of a scenario that actually happened to us, real life. Obviously, after the first release in production, during the night, because it never happens during the day, the track impression service started to fail. Now, when this happens, it basically means that we're losing money, because an ad not tracked is an ad that doesn't get paid. Thanks to the fact that the whole process log workflow is not in the hot path, the user experience from listeners were never impacted. So people listening through Amazon Echo, through Spotify, through Apple Podcasts, they didn't notice anything. But still, we know that if we don't track the impression, we lose money. The dead letter queue started to get messages and triggered an alert. We were paged during the night, and we started working on a solution without the stress of losing data. And this is very important when you work on hotfix. We tested and then released an hotfix. After the release, the dead letter queue stopped growing, and that confirmed that the hotfix actually worked. We then proceeded to redrive the dead letter queue, and all the messages got processed correctly. At the end of the incident, no user was affected, listeners, and not a single impression was lost. What do we want to highlight here? That when we develop core features around revenues, especially, we always try to design around failure modes. So decoupling services with a queue, keeping the consumer of the queue idempotent, monitor the status of the letter queue, are in general simple guidelines that can save you from really bad surprises. The next thing you want to do is look for cost optimization opportunities. And in the next slide, we can see how you can do it, always in the context of this process. SQS is not only good to the coupled services. Another important advantage is the possibility to reduce costs thanks to batching. On the producer side, we can send more messages at once to reduce execution time from producer lambdas and associated lambda cost. On the consumer side, we can receive more messages at once to reduce the number of invocation of consumer lambdas and the associated cost. One of the best things about serverless application, in my opinion, is the complete shift from reliability issues into cost optimization issues. Thanks to the pay-as-you-go model, in general, you can start simple, knowing that the service will scale, and when you see that the costs are getting higher, you can iterate on cost optimization issues. In our experience, this is where the AWS support really shines. I mean, we have with them regular checkpoints with the team to review our spending. And in particular, we found a lot of value in architectural reviews with solution architects to understand how to tackle cost optimization. Before I move to the next slide, is there any question, Rob?
Hey, Manuel, thanks. And thanks, Rocco, also as well for all the information you provided so far. Really interesting stuff on how your journey kind of made. And so appreciate that so far. Did have a question that just came in from the audience from JibJab06. And they wanted to know, Manuel, specifically about what you were just speaking of on the Lambdas. Why don't you call one Lambda from another Lambda?
Calling one Lambda for another Lambda, is fine. You can obviously do it.
Mm-hmm.
The thing is that you are then coupled. The thing is that the first Lambda depends on the second Lambda directly. So as I was saying, leveraging, thanks to SQS, you can leveraging like retries, and you can use the dead letter queue. You can add very simplified monitoring. And obviously, if you need to do a sync operation, because you need the result of that operation, that's perfectly fine to do. But if you don't need that, it's better not to do it, because it really increases the reliability of your service.
Great. Yeah, thanks for the information. Like you said, especially if you're trying to build something that is decoupled, having one depend directly on the other, probably not the best practice for you all. So
yeah. The other thing is that, most of the time when you try to decouple in that way, you're not really decoupling. You're usually moving the codes into two different Lambdas, and you can execute it directly in the first one because it's fake decoupling. But this is an unpopular take, probably.
No, I appreciate the information, honestly, there on it. It is true, right? If you're trying to build something, definitely thought it was interesting the way you're talking about, using SQS and stuff and SNS as fan out methods to be able to deliver these and, like I said, get that distribution. And thanks for sharing the little horror story on, but luckily with the dead letter queue and the bug fix to be able to get that back working and be able to recover everything. So I'll let you continue on here through the rest of your slides, and I appreciate the information so far.
Okay. The horror stories are, everybody has horror stories. The important thing is that you can put an happy ending to it. But let's see what we saw and summarize a little bit the key points that we covered during the overview of this process. We saw how we decoupled services from the listener user experience. This is very important. You have a valuable path for the user experience. You want to decouple everything else that is not strictly relating. We saw how to kickstart services thanks to CloudFront delivering events, dropping logs on S3 and leveraging the events. We saw how to handle failures and simplify data recovery in a very critical service thanks to SQS retries and dead letter queue. We saw how to optimize cost, sending and receiving SQS messages in batches. Before giving the microphone back to Rocco, I want to talk about another big advantage of embracing serverless event-driven architectural pattern. As you may imagine, in our programmatic ad marketplace, we collect and serve hundreds of thousands of different ads every month. And lately, one of the big problems that we have is in the context of ad categorization. Sometimes ads are coming from marketplace and can be miscategorized by mistake. At the end of the day, when there's someone human doing a process, there's an high chance that there's going to be some mistake. Since we give our podcaster the possibility to disable certain ad categories, you can understand how bad it is to hear an ad that you don't really want to be associated with your content. And let me give you an example. Imagine that you have a podcast that talks about fighting climate change, and you get an eye from an oil and gas company. This is something that we absolutely need to avoid. You can exclude it. You don't want that kind of ad. Our business requirement was to add a transcription of all the ads to make sure that we could have the possibility to do a full text search on ad content to track miscategorized ads and have the ability to recategorize ads first manually and then with machine learning techniques in minutes instead of weeks. Because when this happens, you want to be fast. And to make the request a little bit more challenging, because who doesn't love a challenge? All of these had to be implemented independently by another team. And we wanted to have the first step in production in a couple of weeks. So what did we do? We analyzed a little bit the current architecture in search of the correct spot to kickstart the transcription process. We excluded the add server API, that is the component responsible to give back the ads given a target, and the stitching API for the good old reason that we were talking about before. These are in the real-time listening out path, and we didn't want to add latencies and coupling with things that are not strictly related to the listening experience. We want to protect the listening experience. We decided to leverage the AWS event system once again, and we noticed that we remember that, okay, we have a process to encode the add MP3 to match the codec settings that we have, that the episode has. Similar to what we did with the ad tracking, we subscribe to an S3 event as soon as an ad is encoded to start then the process that use Amazon Transcribe to do the hard work for us. We then exposed the output of the transcribed ads in a QuickSight dashboard and made it accessible to our AdOps team. So to summarize, what are the key points here around event-driven architecture? We implemented actually a complex feature at scale in a couple of weeks with a new team without changing anything of the original architecture and without adding latency and complexity to our core functionality. Before we move on with Q&A, if there are questions, I'm passing back the microphone to Rocco for some final consideration. Or if there are questions, Rob, you can go with questions. I don't know. You're the one ruling here. It's your room.
All right. Yeah, we do have a question that came in from the audience from TO310182. Would you suggest S3 as a single storage for an HTTP API process? And what are the pros and cons you could highlight of doing so if you were able? I don't know if either one of you want to cover that.
Okay, I'm gonna.
Rocco, do you want to talk about that?
Yes, I'm gonna take it. No problem. So the unfortunate answer is, as always, it depends, because it always depends on your use case. So in our use case, the need was to have a key value store that was able to expire objects, and that we can also use to easily build event-driven workflow based on what was happening in the storage, right? So with a traditional database, that what we were using before, adding, removing objects is very simple, but they typically lack mechanism for automatic expiration, and you have to also build your own thing on top of it to have events that get triggered every time things change. Other system, like for example Redis, may be better suited for it in general. But in our case, we had a lot of data to store in there, and so the cost of the memory that the system would have needed was pretty high. On the other hand, we did not have like a dramatically strict performance requirements, like 1 millisecond response time for that lookup. We could afford a few tens of milliseconds, and you can achieve that with S3 if you are dealing with it in the right way. I mean, connection pooling, reuse, and all of that. Having a tens of milliseconds response time from S3 is feasible. And in our case, it was exactly enough for what we needed. And so it worked very well.
There's another thing, like Rocco was talking about pooling and things like that, as usually accessing the store only when you need it. So being very careful, like reviewing the process that you are implementing. And another trick that we're using is actually, if we want to check for the presence of something, we just use add requests to S3 that are usually way faster than getting all the information back. These are just like tricks, but they may be useful for people that are trying to achieve the same. And there is fast, also fast as slow is never a problem. It depends on the context. Like 1 second response can be fast in a context, and 1 millisecond can be slow in another.
Yeah, the other trick that is not strictly related to S3, but it's in general one of the foundational decisions that we took is to leverage immutability a lot. Basically, in the platform, everything is immutable. And by definition, it means that everything is cacheable for a very long time. And that helps a lot because you reduce the rate in which you access your storage. And so it helps, smoothing and optimizing the performances.
Great, thanks for that info and everything into considerations on why you all chose to use that, the recommendations for it. So appreciate that. I also appreciate all the information you shared, about just kind of the different ways that you went about adopting this and the timeline that you took in order to move from your kind of older monolithic infrastructure into this event-driven and more flexible model for you all. Rocco, I'll turn it back over to you, I think, for your last bits that you have, and see if you have any other questions when you wrap up there.
Absolutely. Thank you, Rob. Well, I have just one last slide. And so please allow me to steal yet another couple of seconds to wrap this up. So the first service we built with serverless technology was in 2015. So just a few months after Lambda was released at GA. As you can imagine, since then, a lot has changed. Capabilities were added, and we also figured out the way around, this different paradigm of architecting things. And serverless is now a foundational pillar in our architectural decision-making process. So we like to consider ourselves a serverless-first company now in 2022. Every time we have to build something, we ask ourselves, can we make it serverless? And guess what? Most of the time, the answer is very, very often yes. So thank you very much to the attendees for listening so far, and to Rob for giving us the opportunity to present our work on this stage. And we can go back to questions if there are any.
Great, appreciate it. So no new questions from the audience. So audience, if you do have any questions, feel free to post them right now. Rocket and Manuel, I just want to talk a little bit, about kind of the past work that we've done together as far as, should really leverage Uri. That was the big key talking point right on the serverless infrastructure calls that we had while you were going through this, and still just kind of continued one. So, that's just one of the things we try and do support to make sure you could be able to leverage the service, get questions from, an actual serverless expert. I'm certainly not that expert, but I'm glad that we had a way to be able to come in and help to talk with you all about those things. So I appreciate you covering, kind of how we were able to help you with getting some of this up and running. And hopefully, quickly. And of course, we always want to make sure that we're doing things at a very cost-efficient manner, because that's something us TAMs love to do, is make sure we do things well, but inexpensive as well. So
that's something that I actually want to stress again, because I pass on to it and I was like, yeah, we have architectural reviews. We're talking about monthly check with a lot of insights and ideas how to get around bottlenecks and cost reduction opportunities, and actually learning from the AWS support. Hopefully, the AWS support learning something from us. So it always felt pretty good and natural, like we would do it with a teammate working on the same project, and that's super valuable.
Yeah, and Rob, don't underestimate your work, because you facilitated a lot of this. So
no, I appreciate it. So yeah, definitely. So if looks like that we don't have any other questions from the audience. So everyone, today we took a look at how Spreaker from iHeart was able to use our AWS serverless services to go from monolithic to a event-driven architecture. If there are any questions that I missed over there in the chat window today or didn't get answered, please feel free to post your questions on repost.aws, where one of our experts can provide you with an answer for your question, or it can become a topic of one of our future shows potentially. So if you have any feedback for us, check that chat box on the right for the link to our survey, or you can email us at awssupportsyou@amazon.com, because we really do want to hear from you and let us know what else you would like to see on the show. And so if you're interested in learning more about Spreaker, don't forget to check out the links we shared previously about their products and career opportunities. And don't forget to join us next Monday, July 18th at 11 a.m. Pacific. We'll be introducing you all to the AWS Resilience Hub. Thank you for joining us at AWS Supports You, and happy cloud computing, everyone.